Okay, this is going to be a quick video about the normal distribution, which is probably the most important distribution in statistics. And all of the variables in this are going to be continuous, so things like height, weight, or time, something like that. Now, just to show you an example here, what I've got here is the heights of 10,000 Czech males. And from this data, we actually know that the mean of the data is 180 centimeters, and the standard deviation, which is obviously a measure of the spread of the data, is 6.35 centimeters actually. Now, that's what's given by the histogram we've got. Now, if I had more and more people, in fact, if I went if you imagine you could have an infinite number of people, what would happen is it would get closer and closer, the histogram, to this purple line, which is the model for this data, the normal model. Okay, and once we have our model, we can use it to predict or work out the probability of being, for example, between a certain height. So you could work out what's the probability that someone's between 170 and 175 centimeters or whatever. So once you have the model, you can use it to work out probabilities. Now, we're going to use the calculator to work out the probabilities, as I'll show you in a minute. But just some important features about the normal distribution. The normal distribution, okay, has this distinctive kind of bell shape. So it looks something like that. The purple one's a bit better than mine, but never mind. And the key thing is that it's symmetrical. So the mean will be in the middle, and then the probabilities are the same on the left and the right, exactly the same shape. Now, with the normal distribution tells you the spread of the data. And in fact, if you go up and down one standard deviation, basically 68% of the data, roughly, is between those 2 points. If you go another standard deviation up and another standard deviation down, so in other words, from 2 standard deviations below, I'll draw the line up here, to 2 standard deviations above, then 95% of the data is here. So 95% of the data is within 2 standard deviations of the mean. That's how we say it, within 2 standard deviations of the mean. If you go to 3 standard deviations, it actually turns out to be 99.7% of the data. So when you're drawing your sketches, just put a line in the middle and go 1, 2, 3 standard deviations up and 1, 2, 3 standard deviations down, and you know the full thing pretty much will be between those 2 points. Okay, so let's look at how we can find probabilities. So in order to do that, we're going to use the calculator. So I'll just put that on. Now, we've got our mean and standard deviation. That's the thing. They're the things we need to be able to use the normal distribution. Now, the first thing is we generally have a letter to stand for the data. Now, I've used X here, so let's use X again. We use a capital letter, squiggly line, to say that X is distributed normally. And then the first number will be the mean. And the second number is actually the standard deviation squared, so you might see it written like this. But anyway, all we need to know is what is the mean and what is the standard deviation, then we can work out any probabilities we want. So for example, if I want to work out the probability that somebody's height is between 170 centimeters and 182 centimeters, that's how you would write your working out. So so on the calculator, the way to do it is you go to second distribution and go to normal CDF. We only ever need normal CDF. Okay, don't worry about normal PDF, that's just for drawings and stuff. So enter. It always wants a lower number and an upper number. Okay, so this is just, between what 2 numbers do you want to work out the probability of. So here we have it 170 and 182, so we just type in those 2 numbers. Lower is 170 and the upper is 182, and we're looking for the probability between those. We have to still put in the the mean and standard deviation, so 180, and standard deviation is 6.35. Paste that, enter, and it will give us the probability, so 0.566. Okay, other questions you might get is, things like, what's the probability that the height is less than 175, something like that. So, a good idea to think of a sketch in these situations. So, draw a little sketch. Oops. Then 175 is going to be about here. So what we're looking for is what's the probability, or how much of the distribution is below 175. Okay. Now the issue is that on the calculator, go back to normal distribution, normal CDF, you do have to put a lower number in. So obviously we haven't got a lower number. We could use 0 because people can't be lower than 0 height, but the convention is just to use a big number far to the left. I generally use, if it's on the left, I use like a big number like this. Yeah. So I'm going to go from, the reason we're doing that actually is because because it's a model, there is small little tiny area and it goes infinitely in both directions. It doesn't make a difference as long as you go more than like 4 or 5 standard deviations away. It won't make any difference to your answers, but just to be safe, we're going to use a large negative number so we know we are far to the left. So on the GDC, minus, I'm using the minus at the bottom, remember, to enter negative numbers. I just put a few 9s in. 175, and obviously the mean and standard deviation are the same as before. So it's 0.216. If I wanted to work out the probability that somebody, let's say, was taller than, say, 183 centimeters, I'd write it like this. And then on the GDC, this time my smallest number is 183, isn't it? So the smaller number is 183. So in the GDC, that's going to be 183. And my upper number is going to have to be a really large number to the right of all the data. So I'm just going to use some loads of 9s on the end. So I'm way off the scale. Mean and standard deviation is the same. Enter. So the probability is 0.318. Okay, so this is how we find probabilities. So this is the first thing you need to know, finding probabilities. If you have the mean and standard deviation, you just put it in, put what you're looking for in the calculator with the mean and standard deviation, and the normal distribution function on the calculator will work it out for you. So that's the first thing. The second thing is the opposite of that. With that one, we had some numbers and we were working out the probability of being between those numbers or whatever. Sometimes we want to go do the opposite. So I'll give you an example. So if we have some data, and let's say it's exam scores. Okay, so let's say the average exam score was 60 and the standard deviation was 5, let's say. Okay, so and let's say the examiner wants to give the top 20% a grade 7. Okay, so and we're interested in what mark do you need to get a grade 7. Okay, so 1, 2, 3, 1, 2, 3. Now this might be a bit unrealistic because 60, this would be 65, yeah, this will be 70, and this will be 75. So basically 95% of, 99.7% of the data would be, in this case, would be from 45 to 75. So not many people got above 75. I don't know if that's realistic or not. But anyway, let's say for this particular test. Now, the top 20%, so let's say that's here, are going to get a grade 7. So these are the people going to get 7s. And we want to know, what is that score that you need to get a 7? Okay, above what? Yeah. So this is where we know the probability, because we know that there's 20% here to the right of that point. But we don't know actually what that point is. So it's like a reverse question. We know the probability and we are trying to find a number on the scale. Okay, and this is where we use invnorm, invnorm function. When you have the probability on the diagram and you're looking for a number on the scale. So this is how it works. You go to second distribution. This time you go to invnorm and it's looking for the area. So you can see we've got 20%. 20%, but we have to write it, as a decimal. Okay, so we're going to use 0.2. So don't put 20 like I just did. You have to put 0.2 as a decimal. The mean mark was 60 and standard deviation was 5. Now this thing, left, right, center and right, because our probability that we're telling the calculator is to the right of the point we're interested in, then we need to choose right. Okay, if you've got the old software, it's preset for left, in which case if you left it on left, you would have had to put into the calculator 0.8 because there's 0.8 probability on the left. You get the same answer, it's just a different way of doing it. So I'm going to stick to this way because I know it's 0.2 to the right of the point I'm looking for. And then paste. So it's 64.2. So actually my diagram was a little bit off because my line should have been around here, but we didn't know that before we did the question, so never mind. Okay, so it's 64.2 marks. Anyone got more than that, then you got a 7, which is totally kind of unrealistic, I think, isn't it? Unless it was a really, really tough exam. Okay, so this is how you use the invnorm. Okay, I'm going to now do an exam question. So I'll just show you the question. I see the calculators in the way there. So applicants for a job had to complete a mathematics test. The time they took to complete the test is normally distributed with a mean of 53 minutes and a standard deviation of 16.3. One of the applications is chosen at random, right? Find the probability that this applicant took at least 40 minutes. Okay, so first of all, we should write down the distribution. So let's just, well, it's talking about time, so let's use T for time. So time is normally distributed 53 and 16.3 squared. That's how we would write it down. That's part of your working. And the first question is find the probability that the applicant took at least 40 minutes. So T is greater than 40. So we're looking for a probability. So on the GDC, I'll just turn this on. On the GDC, we need to go to second distribution, normal CDF. Okay, so at least 40. So 40 minutes is the minimum. Upper, we're just going to use a few 9s. The mean was 53. Standard deviation 16.3. Paste. So 0.787. Okay, now let's have a look at the next question, B here. For 11% of the applicants, it took longer than K minutes to complete the test. Find the value of K. So like I said before, it's a good idea to do a quick sketch. So we have the mean here, which we know is 53, and it's saying that 11%, so maybe that would be about there. So, and with this probability is 11%, took longer than k minutes. So this k is on our scale. Yeah, and we know the probability of being more than that. So, and we have to remember it's got to be a decimal. Yeah, so this is a case of inverse norm, isn't it? You know the probability to the right of the point is 0.11, and we're looking for a number on the scale. We want a number of minutes, which is on the scale. So it's definitely an inverse norm question. So we're going to go to the calculator, and second distribution, we're going to go to inverse norm, area 0.11, mean 53, standard deviation was 16.3, and yeah, we already had it on right, so it's definitely on right, isn't it, because we've got the probability to the right of the point we're interested in. So we'll leave it on right. So you have to go down and paste. Okay, so K is 72.9. Okay, the last question. There were 400 applicants for the job. Estimate the number of applicants who completed the test in less than 25 minutes. Okay, the first thing we need to do is to work out what's the probability that someone took less than 25 minutes on the test. Okay, so for that, again, we're looking for a probability. So it's second distribution, normal CDF, and we need a lower number. So again, we're going to use a minus number. I'm just going to use minus 999, a few nines. Upper number is 25, yeah? You're going from all the way on the left up to 25 to find less than 25. And this was 53. And this was 16.3. Mean and standard deviation. Okay, and then we just press enter. So basically what this is saying is that there's only about a 4% chance of this happening, that someone takes less than 25 minutes. Actually, these are the top candidates. We need to 3-unit figures. Yeah, but that's only the probability, 4% of them. And we know that there was 400 applicants, so we want to know how many of them got less than 25 minutes. So can you see that we just need to find 4% of 400? But to work out these types of questions, just multiply the probability by the total you've got. So if we just do this calculation, it will tell us the expected number. Yeah. So let's do that. So it's, in fact, I can just times this answer that I had before by 400. And that'll give me 4% of that. So it's 17.2 is the answer.